And again, in theory, much of this will be review, but I'm going to be teaching it as though you've forgotten everything. So we're looking at multiplying polynomials. We're going to skip example 1 and we're going to jump straight to here where it has this. Okay. We've been trying to give you a slightly different way of visualizing polynomials because polynomials are really abstract. I said to you the other day, it's very difficult for me to say, hey, look, there goes an x squared. Well, if I think of them as shapes, I can. We said that if they were shapes, and that's a square, if that's x by x, then the area of this is x squared. That's a picture of an x squared. We said that if they were shapes, and that's 1 by x, then the area, which is length times width, is x. Hey, that's a picture of an x. And we said if we draw a little tiny square that's 1 by 1, well, the area of this is 1. Oh, and we said if they're shaded in, they're positive. If there's nothing inside, they're negative. And I remember nothing in the middle, negative. 2 ends, negative. We're going to try and build on that a bit, but I'll be honest, to me, this is where this analogy breaks down and becomes cumbersome. So I'm going to skip some as well. This doesn't work to me quite as well with negatives. But it says this: complete the algebra tiles diagram to determine the product. Darian, I got to be honest, I would never do it this way. I would do it this way, and I would tell you that I know the answer is 2x plus 6. But there are some, and if you can get that, great, but there are some students who struggle with that. They're visual learners. So I want to give you a second way to think about it. And the second way to think about it is to say, you know what this really means? This really means take this column and draw 2 of them, because it's multiplying by 2. Marcus, what it means as a shape is this. Draw 2 of them. Now, oh, we color it in because it's positive, so let's shade it. You may have noticed I don't shade it in completely. I just kind of go like that and I clue in. If it was a test, I'd probably color it in properly, but here. Anthony, this is to me way easier to do, but I will say that this is probably easier to read. 2 x's and 6. So, okay. But I've already told you I'm not a visual learner. I'm not a big fan of the tiles. I don't find them particularly intuitive or particularly easy to understand, but some of you might. And they will throw a couple of questions like this on the provincial. They'll give you some kind of a picture and they'll say, translate it, explain, what is it? So we'll practice. When I multiply x times x plus 3, now when I do the algebra, what do you get? Brody? I agree, plus 3x. And again, for me, and I think for many of you, that's the easy way to go. But if you want to visualize what's really going on, we're really going x times x. We're really saying you're going to end up with a shape like this, an x squared. And then you're going to end up with 1, 2, 3 x's. Oh, and color them in. Okay, Tyler, I'm kind of buying that a bit. I mean, it's okay. It's coloring in pictures, and in math we don't color in pictures very often. Kind of fun, or it takes me back to grade 3, where I think this analogy gets tougher. This idea of drawing pictures is when you multiply a positive by a negative, like this. First of all, let's do the algebra. Yeah, turn the page, by the way, if you haven't figured it out already. What would negative 3 times bracket x minus 3 close bracket be? Darian? Negative 3x. I agree. I agree. Ah, Darian and I both made a mistake. We went 3 times 3 is 6. What is 3 times 3, Darian? One of the classics. Doubling instead of squaring. Everyone does it. By the way, glad you did it here, because now you probably won't do it on a test or a quiz, right? How would I represent this? Well, here's what how I would represent this. I would say if I'm multiplying by a negative, the color changes. If it was shaded in, it's going to become hollow. If it was hollow, it's going to become shaded in. But I'll be honest, Simi, that's about where I want to stop. Go ahead, behind you. That's about where I kind of, Curtis, stop wanting to care about this method. So I'm going to say, you know what? I think here, if there's negatives involved, I'm going to choose to do it this way. I'm not even going to draw a picture. Same with number 4, although I could probably draw a picture. What is 2x times x minus 2? Yeah.
2x squared
yep.
minus 4x?
Yeah. See, if they really said draw the picture, Alex, you know what I would do? I would do the algebra, that, and then I would draw the picture afterwards, because I find it tough to go from picture to picture with no numbers. Again, that's how my brain works. But what we're looking at is multiplying polynomials. We're going to skip example 5. We're going to skip example 2. And we're going to jump to where this box says to multiply or expand polynomials. And we're going to fill in a definition. Okay. Do you have to have like terms in order to multiply stuff? No. To add and subtract, they have to be like terms. And what do we say like terms were? Same variable and same, begins with the letter E and rhymes with ponent. Okay, same variable, same exponent. So if you want to add and subtract, you have to have like terms. And when you add and subtract, all that changes is the coefficient. The exponents don't change. When you multiply, the exponents are going to change. Now, you may have been given all sorts of little handy-dandy acronyms. Put your pencils down. Some of you may have had a teacher who last year said, who's seen that one? I never quite figured that one out. Anyways, if that's how you remember it, feel free to write it that way. Some of you may have had a teacher who used this word, which is the technical math term, and I'm good with that. Here's what I remember. I want a rule that will, some of you may have had a teacher that gave you this, right? I want something, FOIL is great, but FOIL only works for binomial times binomial. I want to see if I can come up with a general rule that will always work. Set of specifics. I want to memorize less. Here's what I write, and you can pick your pencils up if you want to. I just say this. Everything in the front times everything in the back. If you see two things being multiplied and there's brackets involved, be very careful and make sure you multiply every term in the front times every term in the back, in the second bracket, in the bracket. That's my fallback, works for everything. FOIL is a great shortcut, and I'll use it, but if I forget it, I just go systematically. I better multiply the first two things by the last two things carefully, and then gather like terms. Example 3 says, expand and simplify, A. In the brackets, how many terms is there inside the brackets? What's in the brackets? A monomial, a binomial, a trinomial? Just a monomial. Okay? So this is a monomial times a monomial, and the rule is fairly simple. It's numbers times numbers, letters times letters. It's going to be negative 3 times 5. And then I go letters one at a time. X squared times x squared. Amy, you're right. When I say you're right and you don't speak up loudly, that really means you really don't have confidence. You're right. Speak up loudly. Go ahead. X to the 4th. How about y times y cubed? Careful. You're right.
Why did the 4th?
Why to the 4th? Because there's a visible 1 there, right? Which also reminds us of the rule when you're multiplying and the bases are the same, what did you do with the exponents? You added them. B. Mr. Duick, there's 2 B's. Or not 2 B's. That is the question. Now, let's get rid of this. There. We'll do this B here. Some of you using... Have I done my Doppler effect joke with you guys yet?
Mm-hmm.
Yeah. Some of you, huh? 2B or what? Huh? Okay. Inside the bracket, is it a monomial? No? Then you know what? Everything in the front times everything in the back. Front door bomber, distribute, foot. You know what? It's going to be that times that. I'm lazy about showing work, but drawing the loops takes a half a second, and to me, that's such a good bang for my buck in keeping me from making dumb mistakes. I will almost always draw the loops, even at my age, even now, to remind me that I'm multiplying. You got them all? Perfect. And I think we'll get this. Numbers times numbers, -6 and an x. Negative times negative is a positive, 12. How do you think I would do D? I'll give you a hint. Everything in the front times everything in the back. The other reason I find that one fairly easy to remember, because you really only remember, I mean, it flows. Everything in the front times everything in the back. Many of the words repeat, and front and back aren't too tough. Skip D. Let's go to E. Now, E is written weirdly. E is a binomial times a monomial. Looks a little strange. Anthony, you know what? Everything in the front times. Okay, so it's going to go, this guy's in the front, that's in the back, and this guy's in the front, that's in the back. Okay. Oh, looked weird, but it's not too bad. 2x cubed times 2x, I'm thinking 4x to the 4th, yes? And then positive 5. You notice how I say positive because there's a plus sign in front of it? That reminds me to take care of my positives, negatives, be careful. Positive 5 times 2x, I'm pretty sure is positive 10x. Put your pencils down for 1 second. (3x plus 2, 4x minus 3). You know how I do that? Everything in the front times everything in the back. I would go this guy times that, this guy times that, this guy times that, this guy times that. Oh, you want to give me something really nasty? How about x squared plus 4x plus 3 times x squared minus 6x minus 9. You know how I do that? I'll give you a hint. Everything in the front times everything in the back. I'd go really systematically. So I would say, okay, we're going to go this guy times all 3. Then I'd probably go underneath so it wouldn't be crowded. This guy times all 3. And then I'd probably say this guy times all 3. I'd probably have a bunch of like terms to gather. But as long as I was careful, I wouldn't say it's tougher, Alex. I would just say it's longer, more work. Not really tougher. I guess more room to make a mistake because you're doing more calculations. More room to go 3 times 3 is 6. You know, the stuff our brain does in spite of itself. Let's try example 4. What's that? You want to try this one on your own and see if we end up in the same place? That's a great idea. Sorry? Question? No, I don't mind. I don't mind. I can do it if you want. You okay with it? You want to try it? Okay, I'll freeze the screen and see if we get the same spot. I don't know. I did the whole thing in my head showing no work, so there's a good chance I may have got this wrong. A. Is that right? I could be wrong. I did the whole thing in my head. Really? I got some game. What about C, right? Is that okay? 6x squared minus 14x minus 6? I didn't show my work. I was curious to see if I could do it in my head. I would never do it in my head on a quiz or on a test. And I'm not even sure I would do it in my head in my homework because that was about as much as I can keep track of before, if someone interrupts me, my brain will forget where I was, right? Take a look at C. The weird part with C, I think, is the 9 plus 2. Do I make that an 11? Greg is shaking his head. Greg is right, be afraid. Convince me. Yeah, bad maths, which means I'm going to have to take care of what's inside the brackets. There's nothing inside the brackets, but then I'm going to have to multiply to get rid of the brackets. So I'm going to draw the little loops, going a little loopy. I'll drop the 9 down like a domino. And then I think it's going to be positive 6x plus 14. Am I done? No, there's some like terms I can gather. And I'll go in descending orders. I'll write the positive 6x first. And then I got a 9 and a 14. Last I checked, that was 23.
Yeah.
Let's try F. Don't have to do the 9 as well. Like multiply it in, you mean? What's sitting right there? A plus sign, which it's a great question because that's also a common error. The fact there's a plus sign, that 9 has nothing to do with the bracket. It's not being multiplied in. Darian, do you remember what I said for my little rule? Everything in the front times. What I really should have said was everything directly in the front times everything in the back. This is too far removed. The plus, it's a separate term. Is that all right? Cool. I'm skipping a few because I'm kind of sensing people are doing good on this. Let's try F. Let's try F. By the way, what number is in front of this second bracket sitting right there? It's invisible. I got to be fussy. It's not a 1. It's a negative 1. Yes? Yes? Because that's also the common mistake. Kids forget the negative, right? Negative 8x cubed, that takes care of those. 23x squareds. And I left a term off, Mr. Duick. I'm missing an x right there, aren't I? It's plus 18x, not just plus 18. See, I make mistakes too. I was so proud of getting the minus minus, I forgot the variable. So I'm pretty sure we're going to get Is that right? Do you get negative 8x cubed plus 23x squared plus 18x minus 5?
Yep.
Okay. I'm going to give you 2 assignments. I'm going to give you most of the class to work on it, but then we'll do something at the very, very end. First of all, let me pause this.